Okay, let's look at part 2, or a second video of this. So when we left off last time, we were doing the sum and difference of two cubes. So I'm going to go ahead and knock out these two. All right, the first thing I notice is that I can take a b squared out of both of them. That's it. So what I'm left with is 8b cubed plus 343. Okay, so I know that 8 is 2 cubed. Okay, so what I have is 2b cubed, or not 2b cubed, sorry, plus 7 cubed. I looked at my cube sheet and I saw that 7 times 7 times 7 is 343. So I'm just going to plug it into the pattern. Okay, first term plus the second term. And then, again, I'm just looking up at my pattern here, 2b squared. Okay, I get 4b squared. Minus 2b times 7. 2 times 7 is 14b. Plus 7 squared. And I'm done. I can't break this down anymore. Nothing in here is factorable, so it's factored completely. W cubed minus 27. I've already established that 27 up here is 3 cubed. So what I really have is w cubed minus 3 cubed. And I'm going to follow this pattern, difference of two squares. So I do w minus 3, first term squared, plus them together, plus 9. I'm all done. All right, flip your paper over. I'm going to get a clean copy because I'm pretty sure my pen would bleed through. All right, factoring by grouping. So for some polynomials, you can factor by grouping pairs of items that have a common monomial factor. So in this case, see how we have an a and a b here and an a and a b there? So this is r times a plus b. They basically they undistributed it. Okay, so now we have r times a plus b plus s times a plus b. So now they take it another step. It's r plus s times a plus b. So let's see how we do this here. So what I'm going to do is, for this one, I'm going to take an r squared, and those are both divisible by 9, so a 9r squared, and I'm going to get a 3r plus 5. And then out of these two, I'm going to take out a negative 3. That's a lie. I'm not going to do that. Actually going to take out a negative 1, so minus 3r plus 5. Okay, so that's technically a 1 there. Okay, so 9r squared factored out of these two. Negative 1 factored out of those two. So what I really have is 9r squared minus 1 times 3r plus 5. But I'm not done yet because, oh geez, sorry about that, guys. I was like making the video and not noticing that I was off the screen. So go ahead and catch up real quick. I took a 9r squared out of those two. I took a negative 1, factored it out of those two, so I got a common grouping here. Then I treat it as 9r squared minus 1 times that, 3r plus 5. This is the difference of two squares. So this can be 3r plus 1, 3r minus 1 times 3r plus 5. So all I did was I replaced this with those two right there. So that's the thing about factoring polynomials, is when you get to the end, you got to ask, are there any more puzzle pieces here? Can this get broken down any more? All right, let's look at this one. I have an x, a 7, a 9, and 63. Well, I know that 9 times 7 is 63, so I'm guessing that's where we're going with this. Okay, let's factor these two first, and then we'll do those two. So this is x squared times x plus 7. I'm going to take a negative 9 out of this one, and I get x plus 7. I have to change the sign. Negative 9 times positive 7 is negative 63. So now I'm left with x squared minus 9 times x plus 7. But you guys know I'm not done. That's the difference of two squares. Now I'm done. Okay. Finally, in the quadratic form. Okay, so what you're going to do first is I'm going to factor out my 10. Okay, so I'm going to get 10 times x to the 4th minus 1. Okay, this x to the 4th is really, check it out here, guys. I have an x squared squared minus 1. Okay, so now I have the difference of two squares. So it's 10 times x squared plus 1 times x squared minus 1. X squared times x squared, that's going to give me my x to the 4th. Okay, let's do this one here. Let's see what we all have in common. These are all divisible by 3, and we can take an m squared out of all of them at least. So I'm going to take out a 3, m squared, and I'm left with m to the 10th plus 18 m to the 5th plus 17. All right, so I get 3m squared. This m to the 10th, notice I have a 10 and a 5 here. That's related. Think of this as m to the 5th squared. That gets me m to the 10th, and now I have an m to the 5th, plus 18 m's to the 5th, plus 17. So just think of it this way. What if I had x squared plus 18x plus 17? I'm looking for two numbers that multiply to 17 and add to 18. Well, they'd be 17 and 1. All right? This is kind of the same thing, except instead of an x, we have an m to the 5th. So 3m squared times, instead of my x, I have m to the 5th plus 17 times m to the 5th plus 1. And what I'm going to end up with is m to the 5th times m to the 5th gets me m to the 10th. You add them. 17 m to the 5th plus 1 m to the 5th gives me my 18 m to the 5ths, and then 17 times 1 is 17. It works out. Okay. All right. Factor this one completely. Okay. I know these are both square numbers. I know that 16g to the 4th is the same thing as 4g squared squared. So what I'm doing is I'm looking for patterns that I know, and I know the difference of two squares. So I'm going to see if I can break these down into squares. And then 625 is 25 squared. So what I have here, if I rewrote this as 4g squared squared minus 25 squared. So now I'm just going to follow the difference of two squares. I'm going to jot that down here, so if you had x squared minus y squared, it's just x plus y times x minus y. That pattern we've seen over and over and over again. So I just, instead of x, okay, I have 4g to the 2nd. So I get, that's 4g to the 2nd square root of, actually you don't have to do that, minus 25 and 4g squared plus 25. Okay, last one. 4h to the 6th minus 20h to the 4th plus 24h squared. Let's pull out our common factor. Our common factor will be 4h squared. So 4h squared, and I'm left with h to the fourth minus 5h squared plus 6. So notice how I have h to the fourth and h squared. It's going to be a lot like this problem up here. So instead, let me think of this as x squared minus 5x plus 6. So I'm looking for two numbers that multiply to make 6 and add up to negative 5. It's going to be negative 3 and negative 2. But instead of an x, I'm going to have h squared. Okay. Like that. Okay, and that gives me h to the fourth minus 3. Well, let me just rewrite it this way, 5h squared plus 6, and now I'm going to break it down like we did here. I know these ones are a little bit confusing. I get that. H squared minus 3 times h squared minus 2. And if you expanded this all out, if you multiplied this all out, you used your box method, your table method, you're going to end up with this. Okay? All right.